All right, this is section 410, which you'll notice we've skipped several sections. There are many sections in this chapter that involve matrices. We're going to leave those out until a later date. So our schedule for next week is going to be 410 on Monday, 411 on Tuesday and Wednesday, review chapter 4 Thursday, and take our next test, which will actually be over 3 and 4 together. But they're pretty much the same material anyway. It's just now in chapter 4 we're talking about more than one line. So in section 410, we are graphing systems of linear inequalities. So let me get a graph here. And I believe you've done this before, so it shouldn't be anything new. So this will be a short one. We'll just do a couple examples, and then work on it some more in class. So when you graph a linear inequality, for example, 3x plus 4y is greater than 12. What you're doing is you are showing on the coordinate plane all values, all xy values that make this a true statement. So any xy pair, like if x is 100 and y is 100, then that will make a true statement because those will be greater than 12. So if you plugged 100 in for x and 100 in for y, you'd get 700 on the left, which is definitely greater than 12. So that's just one example of the infinitely many xy points that make this inequality true. And the way you're going to graph them is just graph the line as if it were an equal sign, and then we're going to shade one half of the line. So I'm going to graph this one using intercepts. It's a lot easier than putting it over into slope-intercept form. If x is 0, then y is 3. My y-intercept's 3. And if y is 0, then x is 4. My x-intercept is 4. And I'm going to connect that with as straight a line as possible. However, since this is a greater than symbol and not a greater than or equal to symbol, I need to connect this with a dashed line, which just means that the points that fall on this line do not make a true statement. Okay, for instance, the point 4, 0, when x is 4 and y is 0, that is not a true statement because that gives me 12 on the left, and 12 is not greater than 12. 12 is greater than or equal to 12, but it's not greater than, so I have a dashed line. No points that lie exactly on that line make a true statement. Now you have to decide, are you going to shade above or below? And I want to caution you about the shading. A lot of people will go with this rule: if it's greater than, shade above, and if it's less than, shade below. And a lot of times that is true, but it depends on the form of the equation. If your equation is in mx plus b form, then that's going to be true, but it won't always be true in all other forms. So what you need to do is just pick a test point on either side of this line. So I'm going to make a test point here at the origin. That's usually the easiest one to check. If I plug in 0, 0, I do not get a true statement. And if there's one false point, then the whole side of the line is false. So long story short, the upper portion of this graph is the one that needed to be shaded. And we've already discussed how 100, 100 would work. So any point in all of this area going in all directions, as long as I'm above this green dashed line, it's going to be an xy point that makes my inequality true. Okay, so that goes on and on and on, up and to the right. Anything below this line does not give me a true statement. All right, so all that yellow area is the solution to this first inequality. Okay, so since this is systems of inequalities, I'm going to put another inequality into the mix. And this one's going to be x minus 4y is greater than or equal to negative 8. Okay, and same deal. You can transform it around to graph it, but just pick any 2 points and graph it. If y is 0, then I get x equals negative 8. So here's my my x-intercept. If x is 0, then negative 4y equals negative 8, and y is 2. So there's my y-intercept. Okay, and I'm going to connect these two, but I'm going to use a solid line to connect these 2 points because this is greater than or equal to. So let me find a solid line and connect the dots. So we need to check and see, are we going to shade above or below this blue line? You can do a test point, or let's see, this one's greater than, so we'll check and see if that theory works. Greater than would suggest that I shade above. If I put in 0, 0 as a test point, I get 0 is greater than or equal to negative 8, which is a true statement. So if 0, 0 works, then everything below this line will also work. So this inequality needs to be shaded below. And this shows that you can't always just go with greater than is above and less than is below. If we were to rearrange this and put it into y equals mx plus b, when you divide by that negative 4, you flip your sign to the other way. So that's how that's why we're shading the opposite way, that it looks like you might. So just be safe and go with the test point. Everything below that line, including points on that line, are good. So everything down here, oh, and it overlapped, made green, just like I wanted it to. Wonderful. So all of the blue satisfies the second inequality. All of the yellow satisfies the first inequality. And the combination of those two, this green section, that's the overall final answer to this question. It's all of the points along my blue line, dashed, so up to this dashed line, but not including that dashed line. And all of these points make this true. Okay, so all you're doing is overlapping 2, or it might be 3 in other examples, or 4, as many inequalities as there are. And the overlap of those areas is your final answer. The blue section and the yellow section are not part of my final answer. So if you want to, on your paper, if you want to shade those lightly, that's okay, but make sure you indicate for your answer which part satisfies both inequalities, and that's the only part that matters as far as your final answer goes. So, like I said, you've probably done similar to this before. We'll talk about it in class some more on Monday, and then move on from there. Thank you very much. Young out.